In a previous video, we looked at the difference between the savings annuity and the payout annuity. Savings annuity means I'm making those regular deposits over a period of time and coming up with a big pot of money. And the payout annuity instead is where I have a big pot of money and I'm withdrawing a certain amount over a period of time and depleting it to zero. This video, we're going to focus on those payout annuities. But sometimes the question is, which formula? We've got a couple formulas that involve payout annuities. Now, I will tell you one way to spot the payout annuity formulas versus the savings ones. The payout ones always have a minus exponent. Think about I'm depleting. I'm making the money go down to zero. So it's going negative. It's decreasing the amount of money. So that's how we know that these two formulas here are payout annuity formulas. But the question is, which one do you use? Recall the P sub 0 is the initial amount of money. So it's the big pot of money that you're solving for with the first formula. D is that withdrawal amount. So it's that money you're taking out on a regular basis and you are given the initial amount of money. Okay, so that's those two formulas. So let's see which one applies in this one. You want to be able to withdraw $25,000 a year when you retire. If you expect to be in retirement for 30 years and your account earns 6% interest, how much do you need to have saved? Okay, key words. You want to withdraw $25,000. They're telling me how much I want to withdraw. We want to know how much you have to have saved. How much are you going to start with? So they're telling me I need to find P sub 0, right? So we're going to use the first formula and we're doing $25,000 per year. So our K is 1. That's always a little bit easier. The N is the amount of years, in this case 30. My R is 6%, so 0.06. And I just put all of those numbers into that formula and then try to get it accurately in the calculator. So let's go through that again because this always is a little tricky for students. So let's do some practice. 25,000 times parenthesis 1 minus parenthesis 1 plus 0.06. I don't need the divide by 1. Close the parentheses. Raised to, my exponent is a negative 30 times 1, but that's just negative 30. So 30, make sure I make it negative. Okay, and then close my numerator and then divide that by 0.06. And we're coming up with about $344,120.78. That's how much we have to have saved so that each year we can pull out $25,000. All right, let's take a look at another one. This one says a donor gives $100,000 to a university and specifies that it is to be used to give annual scholarship for the next 20 years. If the university can earn 4% interest, how much can they give in scholarships each year? So this one, you're told the big pot of money that you want to deplete over the course of 20 years. So because I know I'm starting with a big pot of money and I'm using it up, I know it's a payout annuity involved, and I'm given the initial amount and I need to find that annual amount, so I need to find the D in this case, right? The regular withdrawal is what I'm looking for. So we're going to use the second formula over here on the right this time. The P sub 0, how much are we starting with? Well, they gave us $100,000. My rate, 0.04. The K, we're doing annual scholarships, so our K is going to be 1 again. And then my N is going to be 20. All right, so go ahead, pause, try to put this into your calculator, and then see if you get the right answer. All right, so what I came up with when I did this was $7,358.18. If you have problems with that, let me know, send me an email or pop in during office hours and we'll try to figure it out.